today is, oh boy, hold on. Monday, March 16th. Yep, 2015. Algebra 2, 4th period at WSSB.
The day before St. Patrick's.
Yes, that's right. It's the day before St. Patty's Day. We are on 6-2. We're going to talk about what it means to solve quadratic equations. And I have to use this tiny magnifier. So you just have to bear with me. Unless you want to do reading. That's cool with me too. Except Nathaniel, because he reads like a crazy man.
I don't read at all. Read it like a
So,
I should do two hands when reading this time.
somebody read the two little objectives at the top of the page.
Okay.
So what do you learn?
Yeah.
Okay, first we'll learn to solve quadratic equations by graphing.
Mm-hmm.
Then estimate solutions of our quadratic equations
Right. Nice.
by graphing.
So I want to go over the vocabulary.
Exactly. I'm not going to go over the vocabulary. All right. Somebody with a faster brain than me, read the solve quadratic equations paragraph below the why we use this.
How does a quadratic...
The one about the free fall ride?
Below that.
The what?
Okay.
Unless you want to read that. Go ahead if you
Yeah.
want to. Why we use it.
Is it the how
What does it start with?
model?
It's in double caps where it says solve quadratic equations.
It doesn't start with that.
Okay, here we go.
Yeah, I want you to skip that.
Solve quadratic equation. Got it.
When,
Daniel found it. It's on the A.
It's
okay,
right on the top of me.
So who
when a
wants to go?
quadratic,
Oh, Brian's going. Haha.
Go
Go ahead, Brian.
Sorry.
Yeah.
when a quadratic function is set equal to a value, the result is a quadratic equation.
I don't want to hit the wrong button.
A quadratic equation can be written in the form ax squared plus bx plus c equals 0, where
Y'all know
a
that.
cannot equal 0.
Yay.
Mhm.
Okay. Can I read this? No, there's no need to read the study tip.
What's wrong with the study tip?
Can
Well,
I
it
read the
is.
next thing?
What's the next thing?
After the study tip, it's
Okay, Nathaniel.
start with the solutions of a quadratic equation.
Yeah.
Yep.
He's not here right now.
Solutions of a quadratic
I don't know where she is, sorry.
are called the roots
Yep. Root.
of the equation. One method of finding the roots of an equation is to find the zeros of the related quadratic function. The zeros of the function are the x-intercepts of its graph.
That's
These
interesting.
are the solutions of the related equation because f of x equals 0 at these points. The zeros of the function graph below are 1 and 3.
Okay,
Graphic on
let's
the
talk
next
about this.
page.
So, did you notice there's a lot of words that mean the same thing?
Yeah.
Mm-hmm.
The solutions, the roots, and the zeros are all the same thing. Okay?
Redundancy.
They're the same thing. The solutions are when you set the equation equal to 0. The roots are, well, you'll figure that out when we do quadratic. And then, when we do the quadratic formula. And the x-intercepts, all synonymous. Okay? Like my fancy word. They're all the same thing. It's really important to understand that. So,
Synonymous.
synonymous. So look at their little graphic. Okay?
It's
You have a normal, what's this parabola doing?
It's going.
It's going up.
It's opening up. Where's the vertex? Is it above or below the x-axis?
below.
Below. So it's going to cross the x-axis, isn't it?
Yep.
In two places. We can kind of guesstimate.
There's no point on the
Yeah, there
vertex.
is.
It's
There's a
just
point.
the line.
No, actually,
They made points.
my mistake. This goes down.
No, it doesn't.
No, it goes up.
Yeah, it does go up. They made points for the where it
It's
crosses
the
the
one
x.
next to the paragraph, not in the example.
They made points where it crosses the x-axis too, by the way.
They did.
Mhm.
So the solutions to this particular equation,
3 and 0.
it's when y is 0. Okay?
And 3.
So you would say the solutions are x equals what?
Just a point 3 and 0.
And?
A point. Where's the other point?
Where's the other point, Carly?
There's a point at 2.
3 and 0. They're both the same.
No, they're not.
Oh, 1 and 0.
Oh!
It's at.
I was reading that one of the three.
It's at 1, 0.
Exactly. So remember, when y is 0, is that the x-intercept?
Yeah.
Yeah.
Yes.
So that's how you find the solutions. Where does this graph cross the x-axis? Well, it crosses it at x equals 1 and x equals 3. Did you find it, Tanner?
Yeah. I
Okay.
think so.
All right. So does that make sense? That's all you're looking for. Where does this thing cross the x-axis? So sometimes you have to make a table and draw a graph to make this work.
But this graph is a maximum value.
How would you
No, it has a minimum.
No.
It opens up.
math question?
Mine, I think mine's upside
If you
down.
wouldn't mind.
Yeah, what are you talking about?
It's on B290. It's halfway through
Not in
294.
And this
That's
is called
upward. What are
mathing.
you talking about?
I thought upward was a bit.
You think you know, but you don't.
Then that's
No, so it's how the hill looks.
So is where it crosses the x-axis where the dotted line and the other line meet?
Yeah.
What, Bryant? Sorry.
Is where it crosses the x-axis, that's where the dotted line and the other line meet, right?
What other line?
Dotted line and the solid line. You know,
Oh, are you talking about the axis of symmetry? No.
he's talking about where the dotted
Oh,
line
in the
meets the
tactile.
grid.
Yeah, I don't have the tactile. Yeah, it's where.
okay. Now
That's
that
what they're
makes
showing.
sense. I looked ahead a little bit. Sorry.
Okay. So it opens upward because the U is facing upward. Downward makes it look like a print N. Okay. It's a U when it opens up and N when it opens down, if that helps. In print.
Wait, can you repeat that, please?
If it's
If it's a U, it
opens,
up.
yep, and if it's an N shape in print, it opens down. Because the opening of the parabola faces down versus the opening facing up.
Are you sure you don't want to look at me, Tina?
All right, let's do it with the example. Okay. It's the same thing, except they make a table.
We made a table.
So just like in Algebra 1, right, you make a table of values. And remember, 2 to the left of the vertex, 1 at the vertex, and 2 to the right of the vertex. Okay? So,
Solutions.
yep, and there's a hint here. If it says the heading of the example says 2 solutions, what do you think we're going to have?
2 solutions.
Right, exactly.
Horshack believes this book is being really redundant for
It
no
is.
reason.
So let's do it. Okay, so we got x squared plus 6x plus 8 equals 0. We can do some thinking. Opens up or down without even looking at the picture.
Opens down.
Up.
Right, Carly? Because it's x squared, not negative x squared. Has a maximum or a minimum?
Minimum.
Right, minimum. And then if it opens up, it means it has a bottom, right?
Oh.
Uh-huh. Minimum.
Yay, the barrel theory.
The barrel theory,
The
exactly.
barrel theory?
If it opens up, it has a bottom. So this opens upward, so you should think, okay, it has a minimum. That means, and if you check your vertex, what's the vertex? It's
Oh,
x
next
squared
page.
plus
duh.
6x plus 8 equals 0. Always set them equal to 0.
X squared plus 6x plus 8.
Right.
So you move the plus 8 over, I think? No. No, crap.
No,
Solve
it's
this.
already equal to 0. How do we find the vertex? What's the equation?
B over 2a.
Negative B over 2.
Oh, whew. What's
Dang it.
negative b?
Stupid.
Negative 6
Over
over 2. What's negative 6 over 2?
negative 3.
Right, so your vertex x value is at negative 3. Right? Now we've got to find the y value for it. How do we do it?
Plug negative 3 in.
Okay.
So negative 3 squared is 9.
Uh-huh.
Plus 6 times negative 3,
Mm-hmm.
which
Minus-
is negative 8. So minus 18. So it's negative 9. Plus 8 times negative 3 is.
No, it's plus 8.
Plus 8.
Plus 8 times negative 3.
No, it's not 8x.
There's no.
No, plus 8. So
Okay.
That's 1.
Oh, you're
Wait,
scaring me.
It's
Wait.
negative 1.
Negative one, yeah.
Yes. Okay.
Yeah, I corrected
me-
myself.
What was that?
I'm about to
doing
find
it. I need coffee in
You
the
gotta
morning.
slow down, Mr. Baker.
I need coffee.
I actually had a cup of coffee.
Brian. Hi, I was here. Can you call me back?
What would
You
what?
are still here. You have not hung up. Brian says, you need to call me back, but he's still here.
No, but
Threat
Yeah, there's
detected.
2 blue people up here.
can you still hear us?
Bryant, why are you looking so blue?
Colin, can you hear us?
Can either of you hear us?
Can you hear us?
Nope.
Otherwise, I'll read the meeting. I don't want to do
Wait,
that.
wait.
Someone's here. Someone's here.
The motorboat is not defective.
Brian,
Yay.
you have to hang
Hello? Huh. I don't know. Can you hear anything?
Yes.
I hear your motorboat vacuum.
You can?
Yeah, it sounds like a vacuum.
I
Oh,
don't
it means
hear
I'm
right now.
alive.
Very faintly.
Brian, if you can hear us.
Faintly.
I will let you have to
Faintly.
hang up on me
It's very
before
quiet.
I can call you back.
It's not
Oh.
visible as much.
Like my house, or you mean me?
I think it's your microphone or your heater on your computer.
Right. We already discussed the fan.
Okay, well, I should just mute myself and disappear again.
Oh, if you insist.
All right. So we found the vertex. Right. That was -6/3 equals, or over 2. Excuse me. Over 2 equals -3. We plugged -3 in and got a vertex of -3, -1. Right. So if we wanted to pick 2 points to the left of the vertex, I would pick -4 and -5. You pick 2 points to the right of the vertex and pick 0. I mean -1 and 0.
-1 is
wait,
part of the vertex.
No, it's -2, -1.
Oh yeah. Sorry, because it was -3. And they do it for you. I really don't think you need a refresher on how to plug stuff in.
No.
So here it is. We got the points -5, 3, -4, 0. Ooh, that's promising. -3, -1, -2, 0. Ooh, also promising. -1 and 3. Okay. So find the tactile graphic. Okay. Check it out. See where it crosses the x-axis. You can also tell from the table if you use your brain. Okay, now I can call Bryant back.
What's the H2O?
Remember, the solutions are when y is 0 or when it crosses the x-axis.
I only see a partial graph.
I see a weird thing.
Oh, wait, there it is. I found it.
It looks like, it crosses at the x-axis of O.
I'm coming, Bryant.
You know, we already know where the intercept is because on the table, the 0 on the right is 0 on the y.
That's right.
So
You're right, Tom.
X
So you could.
at the-
You're right. You could look at the table and find it too, couldn't you?
It has to be negative.
Yeah.
Because it's one of the only ones that is 0.
So where in the picture does it cross the x-axis?
Below the barrel bottom.
What?
Yeah.
Find
that's what it
when
looks
the
like to
line
me.
touches the x-axis.
Below the x-axis.
That's where the vertex is. That's a good thing. We want that.
Yeah.
It looks like it touches the bottom of the parabola.
If it's not labeled, you're going to have to count.
It's 1 point below the x, and
No, because remember, the solution is when y is 0.
One of,
So it can't be below the x. That would be at y -1.
looks to be like one of.
Find your origin. Where's your graph in comparison to the origin?
Are you in the musical?
Yes, I am.
Vertex.
You tonight.
You are?
I don't care about the vertex. I want the solution.
Oh my God, 9 tickets.
9?
Well, my family.
-1, not quite.
No, it's in one.
Really?
Yeah, they're like, kids are like,
Yeah.
looking for them because they don't have musicals at their school.
Oh, really? Are they all in high
I
school?
think you need a little refresher on how to read these things.
I know how to read them.
Find the origin.
Oh.
It's skewed.
Yeah.
Okay?
It looks
That's why I told you to find the origin.
I
because
found the
I
origin.
found the origin. And it looks
now
like
slide your fingers left on the origin x-axis.
-4, 0,
Yes.
What?
-2, 0.
Am I looking at the right one?
I hope so.
A295?
It's on C294.
We're on page 295.
295?
I mean 294.
Oh, that's why.
Nathaniel,
The wrong one. You said turn to the tactile graphic, and I was right.
the one that you need, not the one that you're not. Brian, can you hear us now?
Yeah.
Oh, good.
Okay.
Sorry, I don't know what happened.
That's okay. The power went out here yesterday. We had a windstorm. It was out, at least at my house, for about 5 hours.
It wasn't
Mm.
scared to do my homework yesterday. I'm sorry.
Yeah, it was lose your word.
Yeah.
So, does that make sense, Brian? Whenever the graph crosses the x-axis is when you have a solution.
They got your
Yeah.
Friday.
Do you see the tactile graphic for example 1?
Mhm.
Okay. Where does it touch the x-axis?
That would be. It looks like 4-0.
Not quite. Are you left of the origin or right of the origin?
It'll be okay. As soon as they're gone, you can play games.
There we go. Now you figured it out.
Yeah, because the f of x is equal to -2, and then -4 is 0.
Oh.
You figured it out, Carly?
I think I might have got.
Do you mean a graph is
Oh.
on
I
something
figured it out from
calculator?
that. I figured it out from
No,
the
you can
pairs.
figure it out there too, but I don't want to go there today.
I figured it out from the
I think I
pairs.
read this wrong.
Okay.
Okay, so.
Yes, it's skewed. Your graph is to the left of the origin. That's okay. Here, and put x value does it touch the x-axis. That's standard.
You know, you can use the Braille code.
Where are you, my origin?
Where are you, my origin?
Oh, origin, my origin.
Your husband comes with you.
Okay.
Your husband comes with you. Mr. Henry's class.
Daniel could help you.
Here it is.
Never mind, she's good.
I think I have it.
All right. Now,
Yeah,
does this
the
make
graph-
sense?
The graph
It's
is
the
the
basic
basic origin.
idea. Exactly. Okay.
I use the numbered pairs.
The graph is left of the origin, and there
Yep.
should be a point at.
That's right.
Should be a point at.
All right.
At 1, 2. -2? No.
Julian.
Yeah.
Yeah, there's
You're
a
totally right. Yep.
-2's? Oh.
Okay.
point there, and then there's also a point at -4.
The -2, 0. Oh, I see.
Right. That's exactly right. That's one solution. When y is 0, x is -2, and then there's one more solution to the left of that.
Is that for -2?
That's right.
That's -4?
It's at -4, 0. Okay. So again, your x-intercepts are your solutions to these things. Okay. And or zeros and or roots. Right. They're all the same thing.
I need to wash his hat.
So, of course, you got to check. The book does it for you. I'm on page D, 294. Okay. From the table of the graphs, we can see that the zeros of the function are -4 and -2. That's all you write. Okay, on your paper you write x equals -4 and x equals -2.
She said that's fine. She doesn't care.
Wait, X.
I'm at the top of D, 294.
I know where we are. That was
Right.
All
Alright, and then you check them. So how do we check? What do we do?
check the solutions by
Check,
substituting in each solutions into the equation.
So
Right.
to each solution into the.
Right, you just plug in -4 and see if it comes out 0. Then you plug in -2 and see if it comes out 0.
-4
8
squared is
plus
16.
20.
Minus 6 times 4 is 24.
Okay.
-4 plus plus -4
Minus
is -24 plus 8. That's 4.
Alright. Check it out. Okay? That's not what's important to me, but always check. Okay, that's some in algebra.
I would say.
Alright, so the graph of the related function in example 1 had 2 zeros. Therefore, the quadratic equation had 2 real solutions. Right? Makes sense? If it crosses the x-axis twice, it has 2 solutions, right? This is one of 3 possible outcomes when solving a quadratic equation. Remember, I talked to you a little bit about this. Okay?
He does.
Yep. Right. So, we can have 2 solutions,
She's doing what you do.
or none. I want you to take a look at these pictures. Pictures.
Do a little bit of daycare after school and then you.
You're on the page. You're on the page or on A.
X up X.
All right. Here we go.
There's an O.
If you have one real solution, what's happening?
Only one dot cross.
But where is this dot?
It's-
-1, 0.
It's the what, Tanner? Not where, like where is it at? It's what part of the parabola is that?
4.
No.
4.
I mean the general term, not
Oh,
the numbers. What do
the
we call
ornament.
that part of the parabola?
X.
The vertex.
Yeah, there.
Yeah. So all quadratics, if their vertex is the only thing that touches the x-axis, then there's only one solution, right?
Yep.
And let's go even further. If it's touching the x-axis, what is y of the vertex? 0. Exactly. So again, if you have a one real solution, that means your vertex is touching the x-axis. Now, 2 real solutions, well, we've already seen that. What does that look like?
2.
Right, it touches twice. Now,
No
look
real
carefully at no real solutions. What's happening?
There's no.
You use elevating.
They don't use O. There's no.
Oh,
wait,
for the origin, right?
wait,
But
there's
what's
no
the
dot. There's no
shape of
dot.
the parabola? Where's the vertex? Approximately, right? Because we're guessing.
It should be above the origin at some degree.
Origin.
Yeah. The vertex is above the origin, and the parabola what? What is it doing?
It's going opening up.
Upward. So is it,
It
ever
opens up.
touch the x-axis?
Nope.
Never. What happens if the vertex was below the x-axis and opened down?
It would touch it.
No, it would never.
If
No,
it
it
was
never touch
below, exactly.
Yeah. 'cause
So
it-
is that also an example of no solution?
Yeah.
Yeah.
Hey, this equation has no soul.
It has no soul, and we can say that. Okay.
Even for an extra for
It's an unfortunate soul.
For an unfortunate soul.
Never mind those.
All right.
You know that song?
Oh, a study tip.
Study tip.
One real solution of a quadratic equation has one real solution. It really has two solutions that are the same.
I like how they
that's
italicized real.
All right,
Italicized.
so we're going to do an example with one solution. Okay?
One real
We already know what it's going to look like, but again, we have to do the same process. We've got to solve it and graph it. But again, we're going to do it, just follow the books, right? But first of all, we need to do some housekeeping on example 2.
Yeah.
Let me see. I don't think so.
Yeah.
Um,
When you bring the 16 across the street.
Yeah, we got to do a lot of things, don't we?
It's 8x squared minus x. No, 8x minus 8x squared equals 16.
negative x squared.
Yeah, you also have to scooch the x squared.
All right, we got to
further
switch
back.
squarities around, don't we? They're in the wrong order.
No, they're not.
8x minus x squared.
I
Is that
have
the right
minus-
order?
I have minus x squared plus 8x minus 16.
You looked at the next line, cheater.
I did not.
Yes, you did.
It's right below the end of that example.
It says write the equation in ax squared plus bx plus c equals 0 form. Now,
Oh,
here's a reminder,
here we go.
okay? If it does not say equals 0, you have to do housekeeping also. Okay?
We did you just add 0?
Yeah, it has to say equals 0.
So
Otherwise,
if it
it's wrong.
doesn't say equals 0, do you put
Move it
equals
over.
0?
Yep, you move it over across the
mean-
street, as you say.
Really?
Yep. Because otherwise, remember, in the beginning it said you have to have ax squared plus bx plus c equals 0.
Yeah.
Otherwise, you're not solving for when x is 0, are you? You're solving when it's
So
all
then
that
you
equal
just
to
basically
5.
flip all the signs until it equals 0.
Well, you just want the right side to equal 0. So if you had, say you had negative x squared plus 8x, well in this case equals 16, right? You move that 16 over, and you would have negative x squared plus 8x minus 16 equals 0.
This.
Okay, that's all it's
smells
asking
like
you to do,
real
is make sure that c term is on the right side of the equation.
Okay.
Well, now we've got it in this right order. So now we need to find the vertex in negative x squared plus 8x minus 16 equals 0. What is the equation of the x vertex coordinate?
So it's negative 1.
Not like JJ, I want you to say it.
Negative.
Negative whatever,
over
what do you...
2a.
Yeah, there we go. Okay,
It's
so...
4. There. I finished it for you. Well, actually, no, it'd be negative 4 because
Negative?
negative times a negative is positive, so it'd be negative 4.
Right, so negative 8 over what?
Negative 2.
Negative 8 over negative 2. And that happens to be 4.
Positive.
Okay?
It can't be negative 2. Because negative 1 times negative 1 is 1. I mean,
No. Again, it's 2 over, negative b over 2a. So that's negative 8
yeah.
over negative 1 times 2, right?
Yes.
So that is,
Oh, yeah.
yeah,
My
careful.
brain process not funny. Ha ha ha.
So we know that the middle of our table is going to be a 4. The left of it is going to be 2 values to the left, for the x's 3 and 2, and to the right 5 and 6.
Yep.
So they get all this stuff, right? Check it out, this little pretty table they made you. 2, negative 4, 3, negative 1, 4, nothing, 5, negative 1, 6, negative 4. Oh, I think by looking at the table we can already figure out what's going on.
Yeah, because what I did when I saw the last one,
Mhm.
I used the pairing, how they paired them with the zeros.
Right, you can.
That's what I did.
You can, I mean, if you find the table,
If there's only one pairing with 0, then it's a one solution.
notice that the graph has an x-intercept of 4. What?
4. And it was negative 4, right? Instead of 4.
No, it's not. He's right. It's
Oh.
right. Because remember, it's 4, 0.
Oh,
Right.
yeah, because you had to.
Thus, the equation
So this-
has one real solution. So let's look at the graph. Look at that here. Turn the page. It's on C295.
Mr. Graph.
Now, I understand you guys why this is so frustrating sometimes because it's like there's all these dotted lines and you're like, E.
I found the origin. It's in the middle of the page.
Let's see. Origin.
Yep, it opens down. Remember, you can use what you learned when you were thinking about it.
Or it's.
Well, it's gross.
There's
Right.
no. Oh, here it is. Let's see.
Okay?
I found the y-axis.
The origin is way off to the left.
Where's
Yeah.
the x-axis?
See, the x-axis are those weird dashed
I
lines.
found
The
the
point's at -1.
I found the origin.
Good. Now move right to find where we think the solution is.
It's L.
One,
Wow.
two,
1, 2, 3,
three.
4.
Boop, 4.
3, 4.
Cha-ching.
So,
0.
and then look. Is this the vertex?
Yep.
Yeah, and which way does it open?
Down.
Down. So
it's
is this
the
our
lid.
only solution?
Hey, it's the
Yep.
lid.
Right. So again, on your paper you would write the solution is x equals 4.
Found the lid.
The lid. Oh, yep. See, it opens downward. So this is also. So this is interesting, right?
There's
This
two-
one solution.
There's guys to the left and to
It's
the
the
right.
solution, the vertex, and it has a maximum of what?
4.
No. The maximum is what coordinate of the vertex?
Oh, -1.
No, 4 is 0.
4, 0.
So what's the maximum?
4, 0.
No.
4.
No. Tanner, do you know?
Was it the maximum x one?
No. That is the
Maximum is 6.
axis of symmetry is the x coordinate. The y coordinate is the maximum, guys.
0.
0! It has a maximum of 0.
I'm not gonna ask because
Ah.
Much.
It is not very much. But in
It's up and down.
Yep, it opens down, so it has a maximum. Okay.
what time is it?
I don't know. I lost my phone. It's here.
I don't know if you guys can tell, but the
Oh, there it is.
the lines that show the x and y axis are a teeny bit thicker or taller.
Yeah, yep. Isn't that weird? Yeah, the
That's how you can
graphics
find
are thinner.
origin easier, possibly.
Yep,
Teeny tiny bit taller, just barely.
barely. I agree. So, this solution. So again, we've now seen 2 and 1. What do you think is next? What do you think the next example is going to be? If we've seen 2 solutions and 1 solution,
No solution.
0 solution. Yeah. So look at example 3. It's on the top of D295
It's on the bottom line.
and bottom of the print page,
Oh!
right after the taxographic theorem form.
X. F
No
of X.
real solutions. Here we go.
F of X is -x squared plus
It's a
6x
hold on.
plus
We got to
2.
think about this. Okay, this is a number theory problem. Okay, it's a word problem. Let's talk about it. Find 2 real numbers whose sum is 6 and whose product is 10.
Oh, interesting. There's not one.
Oh, so 2. Yep. Wow.
Or whose product is 10. So let's think about it. Right?
2 numbers. The sum is 6.
Whose sum is 6 and whose product is 10. Now you could think through it. How do we add 2 numbers to get 6?
3 and 3.
3 and 3. What else?
2 and 4.
2 and 4.
2 and 4.
Right? We're at 9 and 8. What
6
about
and
1 and 5.
Yeah, 1 and 5
And
and 6 and nothing.
6 and 0.
Do any of those multiply to be 10?
no.
No.
We get really
But-
close with 3 and 3.
We can also, yeah, the closest we get, he's right, is 3 times 3 and 3 plus 3. Right? But we can also do this by algebra terms. Let x be one of the numbers. We don't know which one. Right? Hi, Bakar. Good to see you.
Hi, dog.
Right?
Where is she?
She's on the cushion. Alright? Then, to find the other number, we have to do 6 minus x equals the other number. Right? Think about it. The 2 numbers added together equals 6. So if we were thinking in algebra terms, 6 minus the other number is the same as the other number. Alright? Does that make sense how they got the second number? It's 6 minus x versus x.
Yeah.
Kinda, maybe. Right? If you were to solve it,
6 minus.
6 minus the number x is equal to your other number, right?
Yeah.
Yeah. So now you have the 2 numbers written in terms of one variable. Because if we did it x plus y equals 6, that wouldn't do us any good, would it?
No.
So we need both numbers in terms of x. Okay? So now we have it. Now we can write them out. So x plus 6, or the function whose multiple equals 10. Sorry, I'm in the middle of the paragraph where it says plan. Okay? Since the product of the 2 numbers is equal to 10, you know that we can write this equation, x, the first number, multiplied by the second, 6 minus x equals 10. Okay? Bless you.
Powerful.
Then you can use your famous distributing. What's x times 6 minus x, everybody?
X times 6
2x plus
is
2x minus 6.
No, what's 6 times x?
6x.
Right.
Minus
6x.
Minus 6.
Or x squared, I'm sorry.
X squared.
6x minus x squared, right, equals 10. Well, remember,
Needed
it's,
housekeeping.
right, we gotta do housekeeping.
X squared minus 6x equals 10.
No.
But then you move the 10 over.
Negative x squared plus 6x
Minus 10.
minus 10
Oh.
equals 0. Take your signs with you, okay? Now we have it. It's right in the middle of the page. Next, negative x squared plus 6x minus 10 equals 0. Now we solve. What's the vertex?
Negative b over 2a.
Okay. So negative
So it's
Negative
6,
6 over negative
2,
2,
So it's
3.
regular 3. Thank you. Be careful.
Reg
Okay.
3.
Because a negative 6 over a negative
So negative
2 is negative 3.
So negative.
So again, you start your table. There's a positive 3, sorry. You start your table at 3. 2 to the left is 1 and 2. 2 to the right. So here we go. You have 1 to negative 5. 2 to negative 2. 3 to 1. Negative 4 to negative 2. And 5 to negative 5. Do you see
Okay.
any zeros?
No.
No, but look at your y values. They go from negative 5 to negative 4, negative 1, negative 2, negative 5. Does it even...
It doesn't include a 0.
No, it doesn't, because once you get to negative 1, it turns around again. Right? It doesn't even go anywhere near. So look at the very bottom of the page, where I have the little paragraph. Notice that the graph has no x-intercepts. And we know what that means. This means that there's no soul. So look at the graph real quick. Okay? It's on E, 295. That means you too, buddy.
Oh, remember the graph is skewed?
Yep.
Whoa, that's
It's way.
Yeah, that's way out of there, isn't it?
Woo.
It's a barrel theory.
Wait a second. There's a point at the Oh, never mind. It's
So
not
where's the
divergent.
vertex? Is it above or below the x-axis?
Above.
Above.
It is? Where?
It's such a skinny one.
Wait a second. Hold on.
Is it above or below the x-axis?
If the forces are balanced, then it means it's not moving.
It's
If
below.
unbalanced, it
It's
means
below. You're right. The vertex is below. And which way does this parabola open? Down.
Hey, it's a barrel.
So it's after, not a touch.
No.
No. Okay.
Oh, sorry, I misunderstood you.
Yeah,
It's
sorry.
like-
Is the
it's-
vertex above or below?
It's like two-
below and it opens down.
It's like arms.
So the arms, yeah, I was going to say that exactly, Nathaniel. The arms of the
Open.
parabola are never ever going to go anywhere near because they're reaching down below the x-axis.
Forever and ever.
Forever and ever. That's why they have little arrows. Okay.
And they keep getting wider.
Now, let's just do a few of these in the exercises, okay? And there won't be homework if we do them right now. Nathaniel, it is 28. You're good. So let's see. Where'd that darn page
Should
go?
probably leave it 30-ish,
Why?
35-ish. I don't know. Like I might. I don't know.
There's an example 4.
I know, I'm skipping
I'll leave
it.
it
We're going to do it
32.
later.
Ow.
Check for understanding. All right, the homework, or the problems start on 297. Okay?
297.
297.
297.
Are we starting number
Now let's just,
Number 2.
14?
no.
Number 3.
Number 4.
Number 4.
Use the related graph of each equation to determine its solution. So look at the picture for number 4. And find the solution.
1, 2, 3.
Okay.
It's below the. Let's see.
Hey, it's 3. There's negative 3,
Wait, there's one.
and then there's positive 1.
I'm looking at the origin here.
So negative 3, 1. Those are the two that I found, and it crosses the x-axis at 1 and negative 3. So those are the 2 points I found. So now I have to set up a table.
It's negative 4,
It
buddy.
just wants you to solve them. It said look at the picture and solve it. So what are you guys thinking?
Negative 3, 1.
Negative 4.
Negative 3.
Uh-oh. Dun, dun,
Oh,
dun,
he's
dun.
right. Yep. Wait, hang on.
There's
1,
no dots.
2,
Wait,
3.
there's one.
Yeah, you're right. That line is just so faded I can barely see it.
Yeah, these tactographics are a little... What do you...
It's not very good, but
Yeah.
the coordinates are just 1 and negative 4.
Yes. 1, 2, 3, 4. Yep. So on your paper, you would say the solutions are x equals
-4.
-4 and x or x equals 1. Okay. So make sure you write 2 little x equals for each of those.
There's 2 dots on the problem.
So how many solutions does this have?
2.
2.
Dos.
All right. Look at number 5.
Numero cinco.
Number 5 for those.
Equals.
Hold on. Don't. You have a little easier time. Let the Braille readers try a little bit before you shut it out, please.
Equals 2x.
What do you think, Bryant?
What were you asking?
What do you think about number 5 on page 297?
Gross.
Carly says it's on B for boy.
Bees.
I'm the only female student in this class.
You are.
But ironically,
31 if you like.
there's an equal number of females and males in this class, however.
All right.
Not
I'll just
over.
leave you guys off the hook today.
Bye bye.
Bye.
Leaving the book here.
Actually, the
Okay.
guys outnumber us pretty bills.
Well,
What do you think, Brian? I know the tactographics are a little hard to read.
Yeah.
Well, take a gander at it.
Let's see.
See if you can determine the shape of it.
Is it?
Marshall Islands.
It's negative something. I know that.
Yes, that's true. One of them is. One of them is negative something.
Let me see. Yeah.
Brian, if you look at the edge of the graph, there will be arrows pointing to the whichever direction you find. You can follow those arrows the other direction that it points.
Notice that it's skewed with the origin.
Mm-hmm. They're all trying to give you all these hints, Brian.
To find the origin,
Negative.
Her parents are married.
Is it -3?
Close.
Hold on. He didn't tell you.
Higher or lower?
Lower. You overcounted.
Like what's minus yours, and you don't have something.
-2.
yeah, it's -2. You got it.
Origin's in the middle of the parabola.
Oh, wow. There's a point that's, I think it's on the origin.
Nope, it did mark the vertex in your graph.
Oh, vertex.
Don't count the vertex. Make sure you're on the x-axis.